In this lesson, we're going to be looking at linear equations. Now, linear equations have got all sorts of different elements to them. And the first thing you might be able to do is to plot a linear equation. Now, we know if it's linear if there is no exponents to x, so no powers, no x squareds, no x cubes, anything like that, okay? So if there's just a multiple of x, we can expect a linear graph. And if we're not getting a linear graph, we should look back at the coordinates we generated and check them. So I am going to have a look at generating some equations from the formula y is equal to 2x plus 1. So the first thing I want to do is choose some nice sensible values to substitute in for x. So I'm going to go -2, -1, 0, 1 and 2. Okay, those are really nice numbers to work with. Okay, so now I'm going to substitute each one of those in so that I can get a coordinate that matches. So -2 times 2 is -4, plus 1 is -3. -1 times 2 is -2, add 1 is -1. 0 times 2 is 2, add 1 is 1. 1 times 2 is 2, add 1 is 3. And 2 times 2 is 4, add 1 is 5. Each one of these columns is now a coordinate. So for instance, the first one we generated was -2, -3. Our next job is to then plot those accurately onto the Cartesian grid, which is the graph paper with an axis. So let's have a look. We've got -2, -3. That's the first coordinate we should be plotting. Okay, then I've got -1, -1, 0, 1. And now that I've got 3 coordinates in a row, I can see that they're in a straight line. I know I'm on the right lines, but I'm going to plot the others on as well. So we've got 1 and then 3, and then we've got 2 and then 5. Okay, you want a minimum of 3 coordinates before you try and draw the line. Oops. Okay, so that's it. We've generated some coordinates, we've plotted them, and then we've drawn a line through, and we've been very accurate in doing so. Please use a ruler. Please use a pencil also, so that if you do make a mistake, it's easy to rub out, especially plotting those coordinates. Okay, let's have a go at where we go from there. So let's have a look at actually using a line to generate an equation. So there's 2 elements we need to be able to generate an equation. So one of them is the y-intercept. Now that is the word for finding where the line itself crosses the y-axis. Okay, that's the important one, the y-axis. And as you can see here, this one crosses at 2. Now I'm going to write this in a weird way. I'm going to write that c equals 2. Okay, this will make sense in a second. But the second bit of information I need is the gradient of a line. So I am going to plot myself a right angled triangle. Doesn't matter how big it is, how small, as long as it's right. Now, the way that I've chosen to position it is that I've looked for a place where, as you can see here, it crossed a grid in between where all the squares meet, okay? And the reason for that is because it just gives me a bit more accuracy in plotting this. So next, you do my vertical line. Okay, so now I need to count how high my vertical line is. So between -2 and 2, the size is 4. Okay, and then between 0 and -4, the size is also 4. So my gradient, which is how steep the slope is, I'm going to give the letter m to. Okay, now it's the height, the vertical height, divided by the horizontal width. So 4 divided by 4 is 1. Okay, now I'm going to use an equation that is worthwhile you taking note of. So we're going to use y is equal to mx plus c. Really worth taking note of this. Now, m is your gradient and c is your y-intercept. So if I go back, I can write my whole equation out. So y is equal to, now my gradient was 1, so it'd have 1x. Now, algebra, you don't write the 1, so it's x, and then plus where it crosses the y-axis, which is 2. So plus our c value of 2. And now we've generated an equation. Let's have a go at a second one of these. So again, first things first, we want to find where we're crossing that y axis. So our c value, remember, is going to be -2. And now let's make a gradient. So again, we're going to find nice easy places to draw in a right-angled triangle. I'm going to do a much smaller one here. It doesn't matter how big or small. What does matter is, can you accurately read the number of squares? Oops, not quite on the line there, but it's okay. Accurately read the number of squares high and wide. So yes, I can. This is 2 squares high, or actually 2 values high, I should say, and 1 wide. So actually our gradient is vertical height divided by width. 2 divided by 1 is 2. Right, remember that equation. Y is equal to mx plus c. So let's start writing out the equation. Y is equal to m, which is 2x plus c. Now I'm adding a -2, so when you add a negative, it's the same as just putting the negative in. So it's y is equal to 2x minus 2. So remember, that's the y-intercept. Okay, another example. Let's do this one a little bit quicker. Let's find the y-axis intercept. And let's do the gradient. I'm going to just draw this on, but please, in an exam, make sure that you are using a ruler. Okay, so this is 2 over 1. Now notice that this line is sloping from the top left down to the bottom right, which is not the same as our previous example. Let me show you. Okay, so what we have here is a negative gradient. So my c value so far is -4, and my gradient value is 2 divided by -1, because we're going in the opposite direction, and that gives me -2. So when I write out my equation for this line, I've got y is equal to, my gradient is -2, and then my y-intercept is a negative, so I'm adding -4. Remember, that means we're just going to put -4. Oops, I forgot my x value there. Let me just clear that up. 2x minus 4. Okay. Okay, now on the screen in front of you, you should be able to see 2 lines that are running alongside. These 2 are parallel lines, and they will never cross. I'm going to find the equation of the line for the green one, okay? And I'm going to use that to help me find the equation line for the black. So first of all, what's the y-intercept? It's 2, okay? Again, I'm going to do this a little bit quick because we found equations lines so far. So I'm going to draw myself in a right-angled triangle. Please use a ruler in the exam here. It's 1 tall, 2 wide. So what information have I got? My c, my y-intercept is 2. My gradient is 1 divided by 2. Now notice this is in a negative direction, so it's a negative gradient, -1/2. Okay, so my equation for the green line is y is equal to -1/2 x plus 2. What would be similar with the black line? Well, it's got the same gradient because it's got the same slope. It's parallel. So I know for my black line, I can start off in a similar fashion. Y is going to be equal to -1/2 x. But what's different here is that we are not crossing in the same position. We're actually crossing the y-axis at -1. So to finish this equation off, I can just put -1. So we know we've got parallel lines if the coefficient or the multiplier of x is the same as one another. Our last example is going to be looking at perpendicular lines. Perpendicular lines are right angled to one another, okay? Now this black line is the same as the one we've just done. So y is equal to half x plus, minus 1. So let me write that down. Y is equal to half x minus 1. Okay, we know that's the black line. Now, to do a perpendicular line, it's all to do with the gradient, okay? Now, this is going to have the negative, oops, sorry, that should be a negative half. Did I do that on the last one? I did, that's fine. So, negative half x minus 1. So, the green line is perpendicular. Now, the gradient is going to be the negative reciprocal fraction of the original line. Now, what do I mean by that? It means I'm going to write out -1/2, and I'm going to make the reciprocal. So I'm going to put the 2 on top. Reciprocal just means to flip your fraction over, and the 1 at the bottom, okay? So you flip that fraction over, and then you're going to make it the negative. Now mine was already negative, so the black line was negative already. So my reversed version, my negative version, that will be actually positive. So I've really got 2 over 1. So I'm going to start my equation for the green line. Actually, I'm going to start my equation for the green line. Y is equal to 2 over 1, which is 2x. But I'm missing my y-intercept. And actually, I've really popped that quite far down, down here. So it's -6. So subtract 6. And these two lines are perpendicular. So when you're finding a perpendicular line, you're looking for a gradient that's the reciprocal of the fraction you already started. Remember, 2 really is 2 divided by 1. Okay, start with that and you can make a reciprocal gradient. Okay, that's what you're going to cover today. I hope you enjoy it.